Hello and welcome back to the straight line section of the Higher Mathematics course. Today we're going to look at perpendicular gradients, and then we're going to have a go at exercise 13C, trying these questions. That also covers work from 13A and 13B, so it's quite a good exercise to do. So let's have a look at perpendicular gradients, which is on page 6 of our notes. Here we go. So two lines at right angles to each other are said to be perpendicular, so that is a definition of the word perpendicular. So if we find the product of those two gradients, we will get -1. Conversely, in other words, using it the other way around, if the gradient of the line multiplied by the perpendicular gradient equals -1, then the lines are perpendicular. Okay, so how do we find a perpendicular gradient? So say we know the gradient of one line is 2/3. We can simply invert that fraction to make it 3/2 and then change the sign. So the perpendicular gradient would be -3/2. So note, I've underlined this. This rule cannot be used if the line is parallel to the x or the y axes. So because remember, if the line's parallel to the x-axis, the gradient will be 0, and we cannot divide by 0. But we know if the line is parallel to the x-axis, then if we think of a line perpendicular to that, we'll have a vertical line, and we know the equation of a vertical line would be x equals whatever the x-coordinate of that line would be. And again, if we're looking for a line perpendicular to a line that is parallel to the y-axis, the perpendicular line would be parallel to the x-axis, so the equation of that line would be y equals whatever the y-coordinate on the line would be. So let's have a go at a couple of questions. So given the point T and S, find the gradient of the line perpendicular to ST. So let's just find the gradient of ST first of all. So again, y2 minus y1 over x2 minus x1 to find the gradient. So that'll come out as -7/5. So to find a perpendicular gradient, we invert that, which should be -5/7, and then change the sign. So the perpendicular gradient would be 5/7, as MST multiplied by M perpendicular equals -1. Let's try another one. Triangle MOP has vertices M, O, and P. Show that the triangle is right-angled. So I'm thinking, well, a triangle has 3 corners. Which one do I think is most likely to be the right angle? It does say show the triangle is right-angled, so one of them will be right-angled, assuming the question's been written properly. So I'm thinking I don't really want to guess my way through it. If I do a quick sketch, then from the sketch we can tell if it is going to be right-angled, it's going to be at point O, which is the origin. So if I can show that OM and OP are perpendicular, then that means that the triangle will be right-angled. So let's find the gradient of OM. So that turns out to be -3. Let's find the gradient of OP. Again, we're just using y2 minus y1 over x2 minus x1 here. Gradient of OP is 1/3. Now the gradient of OM multiplied by the gradient of OP, -3 multiplied by 1/3 is -1. That means that OP and OM are perpendicular. Therefore, the triangle MOP is right-angled at the origin at 0. And that is your lesson on perpendicular gradients. So have a go at the questions from exercise 13C.